right. And again, I am recording this, so if for any reason you get disconnected or have trouble hearing or seeing it, you can definitely go back and watch it, or if you miss something there, I'll post it later today in Schoology, but there'll be like a little thing that says like digital assignment or whatever from today's with today's date on it. Okay, so I will be checking these page 9 to make sure that you have this done on Tuesday when we get back. Don't forget, mask requirement is going to be in effect, so make sure you bring one. School will have some available for you too, though, but you prefer your own, make sure you bring that again. Okay. So this is back on page 8. Yesterday, we were working on talking about the different gravitational potential energies for both pendulums and found this number here. Now, these are numbers that I had used with, I think this is from you guys. And these numbers should make sense. They are low, but that's because we have a very small mass and a very small height too. So we're going to be dealing with some lower numbers here. But the fact that number 2 was about 3 times as had 3 times as much potential energy should also make sense because it had 3 times the mass. And then 3, how could we have made both pendulums have more higher initial energy, more higher GPE? You could have had the strings set higher. That would have increased your height, and that would have multiplied everything as well. So we'll work on page 9 here. Some will just be questions. There'll be a few that we need to do some calculations for. So number 4 says, what type of energy did the pendulum have after person number 2, that was whoever was holding the pendulum, let go? And so explain how you know. So we know that when we were holding it, it had potential energy, but when we let it go, all that potential energy starts to turn into kinetic. Okay. So kinetic energy, and how do we know? Because it was moving, right? And kinetic energy is the energy of motion, of something moving. In this case, it happened to be falling, right? Falling to earth. Number 5, in the pendulum swing, should it have had when in the pendulum swing, should it have had the most gravitational potential energy? Explain how you know, draw a picture of this. So where in the pendulum swing should it have had the most gravitational potential energy? That should have been at the top of the swing, so like right where you were holding it. Okay, this is where it was at its highest in terms of height. So as far as a picture goes, have your ruler here, and then the string right here, forming a nice 90-degree angle with your washer built into it right here. All right. So number 6 says, when in the pendulum swing should have had the most kinetic energy? Explain how you know, draw a picture of that. So with that, it's when it reaches the bottom of the swing. And that is when it is moving the fastest, or it has the highest speed at the bottom of the swing. So again, if you want to draw this, there's our ruler. Our string's going to be in the middle. our washer right there. Right now, if you guys noticed when you let that go and you kind of let it swing a couple times, right? It never got back up to the height that it started. Like when it swung over to like this side over here, like you let it go from right here, like this picture, it came down and it swung over here, just like that skateboarder when we added friction. It never quite got up to the height that it started at. All right. Without any sort of air friction or air resistance or anything like that, this thing should like theoretically just keep swinging back and forth, just like that skateboarder kept going back and forth across that ramp. But we know obviously that doesn't happen. So this is going to be the highest speed out of any of the other swings. Even if we continue to let this go, the highest speed is still going to be in that first drop. All right, so number 7. 7 is going to take some calculation here. So it wants us to kind of do the same thing that we did for number 1, where I calculated the GPE, the potential energy for both of them. Now it wants me to calculate the kinetic energy for both of these pendulums here. All right, so what we're going to do is sort of split this area in half. You are probably going to need to use up quite a bit of the space. So try to write small. Okay, because this is going to be one of those where we have to do 2 equations in order to get me to solve my main equation. All right, so we know how to calculate kinetic energy. We know that in order to calculate kinetic energy, I need my KE, I need my mass, and I need my V, which is your velocity, aka speed. So I'm going to go ahead and write those down for each of these work areas here. Now in each of these, my kinetic energy is my unknown. Sorry. You do know your mass for each of these. Remember, number 1 is with the 1 washer. Number 2 is with the smaller washer. However, we want to make sure that we're keeping our consistent units. And kinetic energy involves units of kilograms. So I need to make sure that I use the mass of my washers in kilograms. And remember, we had to move those decimal points back. So it's the mass that you used at this point of your GPE equations. Okay. So your first mass is probably around this number here, 0.0077. Again, since all my washers were slightly different, yours might be slightly different too. And then again, because of the combination of washers that you could have, this number might be different as well. But you need to use these 2 numbers, the exact ones that you used over on page 8, move those over here for numbers. Okay, so my mass of my first washer was 0.0077. The mass of my second washer was 0.0229. Bring all those numbers with it, okay? All those numbers with it. Now, for velocity, that's my speed, okay? The best way to find our velocity is going to have to involve using the old equation that I've used. It's been a while since we used this one, but I'll write this off to the side here. A equals, my acceleration equals VF minus VI over T. Okay. What I want to find or solve for is my final velocity. I'll zoom this in here just because it might be kind of small on your screen. Whoops. Go back. Okay. So I want to rearrange this equation, A equals VF minus VI, to solve for my final velocity. I want to know what my final velocity was at the bottom of that swing. All right, so without going over this too much or spending too much time on rearranging this equation, I'm just gonna write it in for us as far as what we need to solve for. So again, but that's where I'm getting it from is the rearrangement of that equation there. So under my letter V here, I'm going to rewrite this equation here for what I need. So to solve for my V, my velocity, which is technically going to be my final velocity, it'll be acceleration times time. So A times T plus my initial velocity. Remember, your initial velocity is your initial speed, right? Your starting speed. So if I plug these numbers in, my acceleration is going to be the acceleration due to gravity, since this is a falling object. So my first number in here will be 9.8 multiplied by my time. Okay, so 9.8 multiplied by your time. Your time is your average. Make sure you're using your average time from your chart on previous page, which for pendulum number 1 would be this number right here. Okay, so it's this number at the bottom of your data table 1. It should be the larger of your 2 times, I believe. Okay, so for me, I'm using the, oh, sorry, I don't know if okay, so I had different numbers. This is from 6th hour yesterday.
10:35.
What, yeah, whose data did I use again?
I think it was me and Damien's.
Okay, what was your number for average time here?
Average time was 0.40.
Okay, and what was your average time for the second data table?
0.35.
Okay, thanks. All right, so I'm going to go ahead and plug those numbers in. 0.40. That was the time with the data that I took from Damien's group. So 0.40. Okay, plus my initial velocity. Now, initial velocity is your starting speed. And remember, this thing is, you are dropping this thing from holding it still. So your initial speed, your starting speed is actually 0. Okay, 0 meters per second squared. So no, or I'm sorry, not per squared. 0 meters per second there for in terms of speed. So really all I need to do is take my acceleration times my time, and that will give me my final velocity. So I have 9.8 times 0.4. You'll have 9.8 times whatever your time was. So I get 3.92, and my units are meters per second. So my final speed in this case, using these numbers, was 3.92. So make sure that you have a number that's pretty similar to this, okay? It'll be slightly different because whatever you had for average time will be different, but everybody has 9.8, but your 0.40 will change a little bit. All right, that was the first equation that we need, but we're not done because now we have to plug in these numbers here using my kinetic energy equation. So that is KE equals 0.5 times mass times velocity squared. So KE equals 0.5 times your mass times your velocity squared. So I need to plug those numbers in. 0.5 times my mass in this case, again, low number. And then my velocity will be 0.2, square that. Right. Take a second and solve yours you need to use a calculator on your phone. Probably use it on your iPad too. So I'm going to solve this in 2 parts just to make sure I get all my stuff done right. So I'm taking 0.5 times my mass. Okay. Second math here, 3.92 squared. Okay, we can round that to maybe just 1 decimal point is fine. So I'm just going to stick 2.4. Don't forget that you need to multiply these 2 numbers together. 16.4 for me, 0.00385. That's what I get for energy here, 0.05. Let's go ahead to 4 decimal points there. And then don't forget your final, which is joules. Since we have a lot of numbers and a lot of calculations, it's probably helpful to put a circle around that. All right. Now, you have to do all that work again for number 2. All right. So I am, let's see. What I'm going to do is I'll kind of stop us here today. What I want you to do is finish up on this one number 2. Okay, so you do the same thing as we did for number 1. If you were following along, everything's the same except your time will be different when you try to solve for your final velocity. You should have a time that's a little bit lower, so that'll make this number a little bit lower. But your mass will be much higher as well. So you should, still get a number here that you can use to compare to. So I'm going to have you guys work on that on your own. We can do questions 8 through 10 in class on Tuesday when we come back, but you're more than welcome to do them if you want now. But I just want to make sure that you guys have time to do both calculations here. I know they take a little bit. So if you want to log off, you can. Just make sure that you get that second calculation done. And I'll stay online in case you have questions. You can stay on if you want to, as how to set this up. But I think if we did it once, you can probably figure it out on your own. So you guys are free to go for the day. Just make sure you have that one done.